Now that you learn what is curve number, now let's solve one example which is very similar to homework question number 4. So this is again on the handout, and I expect you to read that and try to solve it using the same approach. There is no difference between the example questions and the homework, so I was not expecting a lot of difficulties, but maybe that's because I didn't explain what is curve number. So just by reading you might have difficulties. So let me solve these questions. It says that estimate the direct runoff depth and volume using the NRCS curve number method. So it's ask you what is the estimate the curve number, so CN. It says calculate the CN, and it also calculate the depth of direct runoff. So that means it's a precipitation, effective precipitations, and direct runoff volume. So if you know the precipitation and then multiply into area, that will be the volume of runoff. Okay, so that's it. Asks you all those values. Then it gives you all these other factors. It says the precipitation is 127 millimeters. So this is SI unit. So that's what it's trying to say you. And area is for 400 hectares. It says that's the area, and it also says soil group, because that's the total area. This is soil group C. That's important. So this is C. That will be essential to calculate curve numbers. And then it says that 50% of the land use has different types of properties. So it says 50%, 10% for townhouse with a lot size 0.1 hectare. Another is 0.05 hectares lots. And 25% is school, parking lot, plaza, and street car or gutters. And 15% is open space. So all those factors are given. These are all given so that you can calculate the curve number. So let's see what is the curve number for those. If you calculate that value, let's see. So let's say first one, 50% detached house, 0.1. So this is the housing. So if you go back to the original method here, it says this is the one you have to use. Okay, lot size. So it says the lot size is 0.1. So this is given 1.1 by 8 acre, 1.4 acre. So if it is below 1.8, 1.8 is 0.1. So if it is below that one, then you'll use this value over here. Okay, so that's soil group C. So you'll use that value on that locations. Okay, so that's given. That's over here. So I calculate that. For some reason, this one might be a mistake. I couldn't find where is 0.883. That's probably 9. So you have to check that value. Let's see, curve number. It says detached house 0.1 acre lot. So 0.1 detached house. Anywhere it says detached house, is nowhere else. So this is residential district, and if you see 0.05, so that's really low, very small size, and that small size in the lowest you can get is here. So that is 92. So I don't know why it is 83. I don't think it should be 83. So that's 0.9. But let's say for sake of it, this is 83. So what you do is you calculate the total area, so that's 34, and then you calculate the actual, this is curve number. So the real curve number, or the effective curve number, would be sum of area times curve number, okay, divided by sum of area. So that will be 34 400 divided by 400. So that will give you the value over here. Once you know that one, so that's we call CN2. That's the normal moisture content. But it says For this paper, this particular problem, it says that you have to assume antecedent moisture content is 3 type. So that means this is weight area. So if you know the normal area, which is here, normal curve number, you have to calculate that value to the modified curve number based on moisture content. Once you know curve number, you use that value over here to calculate the maximum retention S. That will be in inch by default, based on all that. So you have to convert that into millimeters. Okay, conversion factors. Once you know in S, then you plot in here, then you calculate IA. If you know S, also you calculate effective precipitations. You know precipitation, you will calculate the effective total volume, which is precipitation, effective precipitations times the area, which is 400 acre. So again, this problem is very simple. You just have to know the informations, use the table to calculate the curve numbers. Once you have the curve numbers, then you calculate everything else using the same formula. So it's the same as the rational method. The difference is there you have one C that you calculate irrespective of the rainfall intensity type and land use type. Here you can vary based on all the different other factors. So it's a little bit more complicated, means it takes into account the soil moisture, land use type, residential area, so many other factors. So that's why it's a lot more effective. So that's all for the example, and hopefully you'll be able to solve the question from homework using this exact method.